Okay, we are moving right along in week 8. This is our 4th student learning target, by the end of which we should be able to distinguish if all atoms of an element are the same. Are all atoms of an element the same? Well, let's find out. Let's go back to the atom building workshop. So in our atom building workshop, you made an atom that had 1 proton, 1 electron, and 1 neutron, okay? The atomic number of this new atom is 1. So the atom is hydrogen. However, this hydrogen atom's nucleus has 2 particles. Therefore, this atom has a greater mass than the first hydrogen atom you made. What you have is another isotope of hydrogen. Isotopes are atoms that have the same number of protons but have different number of neutrons. Atoms that are isotopes of each other are always the same element because the number of protons in each atom is the same. Each element has a limited number of isotopes that can occur naturally. Some isotopes of an element have unique properties because they are unstable. An unstable atom is an atom whose nucleus can change its composition. This type of isotope is what we call radioactive. However, isotopes of an element share most of the same chemical and physical properties. For example, the most common oxygen isotope has 8 neutrons in the nucleus, but other isotopes have 9 or 10 neutrons. All 3 isotopes are colorless, odorless gases at room temperature. Each isotope has the chemical property of combining with a substance as it burns, and even behaves the same in chemical changes in your body. So, can you tell one isotope from another? You can identify each isotope as an element by its mass number. The mass number is the sum of the protons and neutrons in an atom. Electrons are not included in an atom's mass number because their mass is so small that they have very little effect on the atom's total mass. So let's look at this isotope of boron. Each of these boron isotopes has 5 protons, but because each has a different number of neutrons, each has a different mass number. So in the first one on the left, we have 5 protons, 5 neutrons, and 5 electrons. The mass number is the number of protons plus the neutrons, which means it has a mass of 10. The second one on the right-hand side has 5 protons, 6 neutrons, and 5 electrons. Therefore, its mass number is 11. To identify a specific isotope of an element, write the name of the element, followed by a hyphen, and the mass number of the isotope. A hydrogen atom with 1 proton and no neutrons has a mass number of 1. Its name is hydrogen 1. Hydrogen 2 has 1 proton and 1 neutron. The carbon isotope with a mass number of 12 is called carbon 12. If you know that the atomic number for carbon is 6, you can calculate the number of neutrons in carbon 12 by subtracting the atomic number from the mass number. For carbon 12, the number of neutrons is 12 minus 6, or 6. Most elements found in nature contain a mixture of 2 or more stable, non-radioactive isotopes. For example, all copper is composed of copper 63 atoms and copper 65 atoms. The term atomic mass describes the mass of a mixture of isotopes. Atomic mass is the weighted average of the masses of all the naturally occurring isotopes of an element. A weighted average accounts for the percentages of each isotope that are present in copper. Copper, including the copper in the Statue of Liberty, is 69% copper 63 and 31% copper 65. Therefore, the atomic mass of copper is 63.6 AMUs, or atomic mass units. The copper used to make the Statue of Liberty includes both copper 63 and copper 65. So, our learning target. Are you able to distinguish if all atoms of an element are the same? Are they? If they aren't, how are they different? Take a moment and think about this. If you can't come up with an answer on it just yet, please feel free to go back and listen again.